Okay, this is number 4 on 16.4. We want to find the area of the region given by y equals 2x plus 1 and y equals 4 minus x squared using a line integral. So, okay, that is this region right here. The left-hand intersection point is -3, -5. The right-hand intersection point of the two curves is 1, 3. I'm going to call the linear segment C1, and I'm going to parameterize it so that it's traveled in a counterclockwise fashion. I'm going to call the parabolic segment C2, and I'll think of that segment as being traveled also in a counterclockwise fashion. Okay, so I'm going to need to think of a single curve C as the union of C1 and C2, and I'm going to parameterize C1 so that well, I'll let x equal t and y equal the 2x or 2t plus 1. Where t goes between the first coordinates of the two intersection points. So t goes from -3 to 1. And I'll use the area formula, the integral over c of x dy to calculate the area. And so that the area becomes the integral over c1 x dy plus the integral over c2 of x dy. And what I'll do is I'll calculate these line integrals in two separate pieces. So the first one, the integral over c1 of x dy, is going to be the integral from -3 to 1. X is just equal to t, and I didn't calculate it, but dy is going to just be 2 dt. So filling in dy, I just get 2 dt. And if you calculate that integral, you just get -8. Now, for C2, I'm actually going to parameterize -C2, which simply means, that notation just means I'm going to travel along the curve. I'm going to think of traveling along the curve from -3, -5 to 1, 3 in a clockwise fashion, just because it's easier to parameterize. And I'll show you how to take care of it when you're doing the integral in a counterclockwise fashion. I'll show you how to take care of that in just a minute. So -C2 is going to be parameterized again so that x equals t and y equals 4 minus t squared. T will again run from -3 to 1. And I'll only need dy, so dy is -2t dt, which means that the integral over -C2 of x dy is going to be equal to the integral from -3 to 1. X is t, and dy is -2t dt. Okay, if you calculate this integral, well, okay, it'll be -2 out in front, integral from -3 to 1 of t squared dt, which means it's -2 thirds t cubed evaluated from -3 to 1. Or -2 thirds times the quantity 1 minus -27. negative 2/3 is 28, or negative 56/3. But that's the value of the integral over negative c2. So the value of the integral over c2 along c2 is going to be equal to 56/3, which means the integral over c of x dy is going to be negative 8 plus 56/3, which turns out to be 32/3.